Good morning, children. My name is Richa, and today we will be talking about Chapter 7 Physical and Chemical Change. So, before we go into the topic, let's talk about the word change. What does the word change means? So, the word change means to make or become different. So, whenever a substance changes its shape, size, color, or a new substance is formed, it is a change. So we know change is the only constant and changes keep on happening all time around us. Let's talk about change in terms of science. So if I talk in terms of science, changes has been divided into basically into four types, that is reversible change, irreversible change, physical change and chemical change. So if I talk about reversible change, when a change in substance can be reversed by changing the conditions, the change is said to be a reversible change. Now what do I mean by that? Say for instance, I have ice. If I increase the temperature, the ice changes into water. Now if I decrease the temperature to its freezing point, water changes to ice. So this kind of change is a reversible change. Irreversible change. If a substance cannot be brought back to its original state, it is said to be an irreversible change. Most of the chemical reactions are irreversible change. Say for instance, if you burn a paper, paper changes into ash. So you cannot get back the paper from the ash. This kind of change is said to be an irreversible change. About physical change and chemical change we will be talking about in detail. So let's talk about physical change first. So if I have to define it, I'd say physical change is a type of change in which no new substance is formed and there is change in the shape and size of the matter. Now when I talk about this, what do I mean? I mean to say, whenever a physical change takes place, the individual constituents retain their own properties. That is, no new substance is formed when two elements or two substances react with each other or they are mixed together. So mostly the physical changes are of reversible type, means you can get back the original form by simple physical methods. So if I say tearing of paper, what do you consider tearing of paper as? Now, tearing of paper, when you tear a paper, it changes its shape and size, but the original properties of paper remains the same. The paper does not change. However, you cannot get back the paper in its original shape. So this type of change is known as irreversible physical change. So as I told before also, physical change or the substances in physical change, whenever physical change takes place, they can be easily separated or original form can be got back by physical methods like filtration, distillation, condensation, etc. So if I talk about a few physical changes, the few physical methods of changes are like the boiling of water. Once you boil the water, you can get back the water by the process of condensation. Making of sugar solution. When you dissolve sugar into the water, you get sugar solution. Now you will say it is a new substance. No, it's not a new substance. Water and sugar retain their individual properties. So when you boil or distill this sugar solution, water is collected in the other flask through the distillation tube, whereas sugar remains in the distillation flask. So sugar and water can be easily separated. So a sugar solution or making of a sugar solution is a physical change. Melting of ice. When ice melts, you get water. So water, when it freezes, it becomes ice. So the form is again got. So all these types of changes are called physical change. So let's talk about chemical change now. So if I have to define chemical change, it is a type of change in which new substance with new properties are formed. So what do I mean by this is, in case of chemical change, the initial substance changes into a new product with completely different properties. Say for instance, my previous example, when a paper burns, it forms ash. Paper has a completely different properties from that of ash. And ash cannot be reversed back into paper. So mostly the chemical changes are an irreversible change. Now, chemical change, the products of the chemical change cannot be separated by any physical methods like filtration, condensation, distillation, evaporation. Some of the examples of, if I take of chemical changes, are rusting of iron, burning of magnesium ribbon, etc. We will talk more about chemical changes in our next slides. Now let's talk about a chemical change involving burning of magnesium ribbon. In this experiment, what you need to do is, you have to take a magnesium ribbon and you have to clean it with a sandpaper or rub it with a sandpaper. Now why do I say you have to rub it with sandpaper is, magnesium reacts with oxygen to form a layer of magnesium oxide on it. This magnesium oxide acts as a protective layer and prevents it burning. So when you rub it with sandpaper, the upper layer is removed and it is easy for the magnesium ribbon to burn. Now, when this magnesium ribbon is burned, it burns with a dazzling white light and a powdery ash is formed. Now, this powdery ash is nothing but magnesium oxide. So, magnesium oxide has a completely different property from that of magnesium, which is a metal, and oxygen. So this type of reaction is a chemical change. Now what you need to do is take this magnesium oxide powder or the powdery ash and mix it in water. The reaction which takes place is, magnesium oxide reacts with water to form magnesium hydroxide. Now we have to check the acidic or basic property of magnesium hydroxide. So I think everybody of you know about the litmus paper test, in which says when blue litmus changes to red color, that means that particular substance is acidic in nature, whereas if a particular substance changes red litmus to blue, then it is said to be basic. Now when you put a drop of magnesium hydroxide on red litmus paper, it will turn blue. Thus shows that magnesium hydroxide is basic in nature. Now let's talk about the characteristics of chemical change. So what do I mean is, if a chemical change has taken place, one or more of these features will be shown. So some of these characteristics are evolution of gas, change in color, change in temperature, and production of sound or change in smell. Now if any of these characteristics is being shown, that means that particular substance is undergoing a chemical change. Now let's talk about chemical changes involving evolution of gas. So some of the chemical changes will be characterized by evolution of gas. Now I'll take one experiment to explain this. Take a test tube and put some zinc granules into it, and with the help of a dropper, add some dilute sulfuric acid to it. You will observe that bubbles of some gas is coming out of it. Now to check which gas is it, what you need to do is just bring a burning sphincter on the mouth of the test tube. You will see that the gas coming out of it starts burning with a pop sound. Now you know, if a gas burns with a pop sound, the gas is none other than hydrogen gas. So if you see here, zinc granules had reacted with hydrochloric acid to form zinc chloride and hydrogen gas. So in this, gas is evolving and zinc chloride has completely different properties from that of zinc and that of hydrochloric acid. So this type of reaction is also a chemical reaction. So in this reaction, gas is getting evolved. So this change is characterized by evolution of gas. Now let's talk about chemical reaction which takes place with change in temperature, or chemical change which takes place with the change in temperature. The same above reaction which we have seen related to zinc and hydrochloric acid will perform the same reaction. When you take zinc granules in a test tube and touch the base of the test tube, you see that the test tube is at normal temperature. Now start adding dilute hydrochloric acid to it, and the reaction between zinc granule and hydrochloric acid takes place. After the reaction has taken place, touch the base of the test tube. You will feel it is warm. This shows that this particular reaction has taken place with change in temperature as well. Now, in this case, heat is liberated. That is why the base of the test tube is warm. And such reactions which takes place with the liberation of heat, it is said to be an exothermic reaction. Exo means out, thermic means heat. The reaction which takes place with the liberation of heat called as exothermic reaction. However, few chemical reaction takes place with the absorption of heat energy, and such reactions are called endothermic reaction. Endo means inside, thermic means thermal, that is heat. So the reaction which takes place with the absorption of heat energy, it is endothermic reaction. Now let's talk about a chemical reaction which takes place with change in color. Now this is an interesting experiment. In this, clean an iron nail with a sandpaper. Now why am I again saying clean it with a sandpaper? We know iron will have a layer of iron oxide on it, and that may hamper with the reaction. So, and then place it in copper sulfate solution. We know copper sulfate solution is blue in color, and when iron nail is placed in it and left for some time, you will see after some time the solution becomes green in color and the iron nail acquires a thin layer of copper in it. This is because iron nail reacts with copper sulfate to form ferrous sulfate, which is green in color. Thus, a few reactions are characterized by change in color. Here you see ferrous sulfate becomes green, whereas copper sulfate was blue in color. Also, iron nail, which was grayish in color, has now changed into reddish brown color, right? So like copper. So that is why this reaction is said to be a chemical reaction, because there is change in color. So let's talk about certain chemical changes which takes place with the production of sound and change in a smell. Now when a cracker is burst, an explosion is heard. Now why does a cracker burst with a crackling sound? Now crackers are filled with lead oxide, which when burns forms lead atoms, which vaporizes. Now since the crackers are these lead oxide and lead is confined within a small space, when vapors are formed, it exerts pressure and it bursts, and when these vapors come out of it, it produces a crackling sound. Now this is also a chemical reaction, because here lead oxide is getting changed into lead atoms, so which has completely different properties, and hence it is a chemical change. When hydrogen burns, it burns with a pop sound, so it is also a chemical change. So certain chemical changes takes place with the production of sound. Now when we talk about some changes related to smell, say for example your food, when it is spoils, it emits foul smell. Why is that? Because there are certain biochemical reactions taking place inside the food, and which emits foul smell. Now why I am calling it as a chemical change, because when once a food is spoiled, you cannot reverse this, so it is also a chemical change. So all the above reactions that we have discussed is a chemical change, as it takes place with the change in the properties of the initial substance, we call it as reactant, and the product formed has completely different properties from that of the reactants. So this is all about chemical changes. Let's talk about some more chemical changes. Now when coal, which is a form of carbon, is burnt in the presence of oxygen, it forms carbon dioxide. Now carbon dioxide has a completely different properties from that of carbon and oxygen, and hence it is a chemical change. So if you consider combustion or burning is always a chemical change. You burn anything, the product formed will have a new property and it cannot be reversed. So combustion is always a chemical change. Now let's talk about another reaction, which other chemical change I say, which you can do it at home also. To take some vinegar in a test tube and add a pinch of baking soda. All of you will be having baking soda in your houses. You will see bubbles of gas coming out with a hissing sound. Now what is baking soda? Is sodium bicarbonate when reacts with acetic acid. So your CH3COOH is your vinegar. It forms sodium acetate, water and carbon dioxide gas. This carbon dioxide gas comes out of the solution forming a hissing sound. Now how do I check whether this gas coming out of it is carbon dioxide? So when you bring a burning sphincter near the mouth of the test tube, you will see that it gets extinguished. We know carbon dioxide does not support burning. So it proves that the gas evolved as carbon dioxide. Another way of confirming that the gas coming out of it is carbon dioxide is by when the carbon dioxide gas is passed through lime water, it forms white solid substance called calcium carbonate. And this calcium carbonate will turn the lime water milky. So whenever carbon dioxide is passed through lime water, it turns milky. This shows that the gas evolved during this reaction was none other than carbon dioxide. Now let's talk about the most common chemical change which takes place around us, that is rusting of iron. So rust is a reddish brown substance that occur on the surface of iron articles when they are left exposed to air. Now what do I mean is, when iron is exposed to air, air has got moisture. So these iron articles in the presence of moisture and oxygen reacts to form rust, that is hydrated ferrous oxide. So this hydrated ferrous oxide is rust. Now my question is, what do you think? Can rusting of iron take place under any condition? No. For rusting to take place, presence of oxygen and moisture is essential. Let's explain this with the help of an experiment. Now take 3 test tubes and place some 3 clean and shiny iron nails. Now in first test tube, put some anhydrous calcium chloride and cork it. Now anhydrous calcium chloride absorbs moisture. So all the moisture which is present in the test tube will be absorbed by anhydrous calcium chloride. Now this test tube has got air but does not have moisture. In test tube 2, add boiled water. Boiled water means air is removed from it. So add some oil on it so that it forms a thin layer above water and does not allow air to get dissolved into it. Now in another third test tube, add ordinary tap water and cork it. What do you observe? You will see the first and second test tube, the iron does not get rusted. This is because in the first one there is no moisture, only dry air cannot cause rusting. In the second test tube there's no air. It has moisture but it does not have air. So alone moisture cannot rust iron. In third test tube, the iron gets rusted. This is because third test tube has both air and moisture in it. So the iron nail gets rusted. Thus, from this experiment we conclude that both air and moisture are essential for rusting to take place. Iron is one metal which is most commonly used, and rusting can degrade its quality. So there are ways by which we can prevent rusting. Coating an iron article with paint cuts off the contact of iron articles with air and thus prevents rusting. Coating an iron article with grease has the same result. Grease cuts off the contact of iron articles with the air and thus prevent rusting. Another process is known as galvanization. Galvanization is a process in which a thin layer of zinc metal is layered on the iron articles. Now when a layer of zinc is present on the iron articles, the air cannot come in contact with the iron and thus it prevents rusting. Another method to prevent rusting is alloying. The most common example of alloying is your stainless steel. You would have seen stainless steel does not get rusted. So if I talk about an alloy is a substance formed by mixing 2 or more elements together where one of the element is metal. So in case of stainless steel, it is an alloy of iron and carbon. And by this you see, when you make an alloy of iron and carbon, the stainless steel does not get rusted. So alloying is one method by which we can prevent rusting. Remember, an alloy is an homogeneous mixture. Now let's talk about crystallization. So crystallization is a process in which crystals of solute is formed when a saturated solution at a particular temperature is cooled. Now what happens is, during crystallization, when you have a saturated solution, that means the spaces between the liquid molecules has been completely occupied by the solute particles at that particular temperature. Now when you start cooling the solution, what happens is the space between the liquid molecules start decreasing, and since the space between this liquid molecules start decreasing, the solute which is present in that space are removed. So these solute particles come out in the form of crystals, and this process is known as crystallization. So it is also a solid liquid purification method or separation technique in which mass transfer takes place from liquid to pure solid crystalline phase. So this process of crystallization is used for purifying many types of solid. Now let's talk about an experiment which you can perform, that is formation of crystals of copper sulfate. Now what you do in this is take a test tube and half fill it with water. When the water starts boiling, add copper sulfate to it. Keep on adding till the water can no more dissolve copper sulfate into it. That is, you have to make a saturated solution of copper sulfate. Now what you do is filter this copper sulfate solution to get a clear solution and leave this test tube undisturbed for a certain period of time. After some times you will see the crystals of copper sulfate are present at the base of the test tube. So this is how crystallization takes place. So with this I end my presentation on physical and chemical change. Thank you for watching my videos. If you like, keep visiting my channel to view more such videos. Thank you.